Hey there, guys. Alright, so for this video we're going to talk about motion diagrams. I'm going to try and make it quick, but I'm going to try something new here. So Micah asked if we could have my face for the entire video. So I'm going to try and do that. Now my mouth probably isn't going to match up with the words, but I am going to see if I can leave my face on this thing for the whole time. And probably won't look like I'm looking at you. And I don't know if this thing's going to move around and how it's going to work, but there's me. Okay, so like I said, this is motion diagrams. So let's draw that here, motion diagrams. Now I am going to, you should see me writing now, and I'm going to continue doing that. All right, so motion diagrams. So first off, let's do a quick definition of motion diagrams. Okay, motion diagram is a drawing, all right, that represents, oh, don't draw onto the thing, there you go, that represents a moving object. And I apologize about my handwriting. I'm still trying to get good at this new app. All right, so a drawing that represents a moving object. Now, how to create a motion diagram. Here's what we have to do. So we always start, so step one, okay, start by drawing an axis. Okay, so an axis, let's remember that an axis is always going to look like this. Okay, so one thing that always has to be on every axis is a 0. And I'll put a little note here. Let's see, I was thinking about, can I zoom in? All right, so my face is gone for a second. Sorry about that. Okay, and we're going to write here, don't forget the 0! Exclamation. Alright, let's see now if I can zoom back out so we can see my face again. Hey, there I am. Alright, cool. Alright, so start out by drawing an axis and don't forget the 0. Alright, so another important point here, okay, so notice that on this axis, as we're looking at it here, this axis, there's no other lines. So I know that in the football example, we drew like 10, 20, 30, 40, that kind of thing. On our motion diagrams, we don't have to have any numbers except for that 0. The 0 is the only thing you need. Okay, so now step 2 here is going to be draw dots above the line. Okay, now what we need to do, or what we need to remember about the dots, is that each dot is going to represent the location of your object at a certain point in time. Okay, so if we're putting a dot there, that means that your object was at that location at a specific point in time. And then the next dot is you know, where it's at after that certain time interval. And the next dot is after another time interval. So when we were out on the field, it was every 3 seconds. Maybe it's every 1 second in some of these other ones. Maybe it's every 10 seconds. I don't know. But as long as the times between the dots have to be equal. All right, so after that, now I'm going to have to move me down there. And let's see if I can do this. Cool. Okay. All right, so step 3, okay, is going to be to connect dots with arrows to show direction. All right, so our dots have to have arrows between them in order to show what direction we're going. All right, so let's draw a couple of examples here, okay? So we'll go examples. All right, and again, let's move. We'll put me right there. Okay, so let's just say that we've got a, oh, what an ugly line. All right, so let's just say that a little bit better. So we've got a car that's moving down the street. I'm going to make it a little bit bigger so I can. All right, and so it starts there. Let's go even a little bit bigger. There we go. Dot. All right, and then it's moving along down the street. And we've got a motion diagram. I don't like that last point. Let's erase it. That's okay. We've got a motion diagram that looks something like this. So step 1 was to draw an axis with a 0. Step 2 is to put the dots right up here above the line. Step 3 is going to be to draw arrows. So I'm going to say this car was moving left to right. These arrows show me left to right. Okay, now I'm going to draw a second one, and we're going to compare. So now let's say there's another car moving down the street. So I've got my axis, and I've got my 0 down here. And now this car is going a little bit faster. Okay. So now I've got my dots. I've got my arrows. All right. Now there's a couple things that we need to see here, okay? So the first thing we need to see is right here. On this one, I'm going to say bigger dot or bigger spaces equals faster. So if we think about it, okay? So we think back to our football field activity. When we were going faster on the football field, the spaces ended up bigger. And when they were slower, those dots were all really close together and the spaces were smaller, okay? So bigger spaces equals faster. Oh. Don't do that. Go away. There we go. All right. Now, the last thing that we want to say here, so bigger spaces equal faster. I want you to put this really big down here at the bottom, okay? Equal spaces means constant speed. Okay? So let's make sure we get that drawn. If you have a highlighter or something like that, you can highlight that, put it in a box. But we have to be able to see that as long as these things are equally spaced, that means it's moving at a constant speed. If the spaces start to change size, that means that we're slowing down or we're speeding up. All right. Now, oh hey, there's Mr. McSparron back again. All right, guys, hopefully you enjoyed that video. Again, please give me feedback on whether you liked or didn't like this whole video on the screen thing.